Hello and good day. In Algebra, we'll be covering CO1, our first objective of the year, classifying a number as rational or irrational. So when we went through the binder sheet symbols, the wise old owl, that represented some sort of term, definition, something that we needed to define. And we're going to start with the rational and irrational numbers. Can somebody tell me what a rational number is? The definition of a rational number. Yes.
By dividing an integer?
Sorry, say it again.
It can't be made, a number that can't be made by dividing an integer.
A number that can't be made by dividing an integer. Well, fractions are part of a rational number, or that rational number set. So fractions are valid, dividing an integer by something. Okay? A rational number is a value with a decimal that ends or repeats. A rational number is a value with a decimal that ends or repeats. Again, all the side comments, the stuff I really appreciate, and you will too if you don't make them now. So, for example, the number 8 is rational. Even though it's not written as a decimal, can it be?
Yes.
What is 8 written as a decimal, Sebastian? 8.0. Okay, that's a decimal that ends. Therefore, it is rational. Question, yes?
Not a question, but so it's basically anything that can be divided downwards or like subtracted.
No, not really, because we will get to the point where we can subtract irrational numbers when they're written as roots. But basically, everything that you've worked with so far in math has been a rational number. You don't really get to the irrational number set until, well, now. So, a number like negative 7.34, a decimal that ends, that would also be considered rational. Another example of something that would be rational, the fraction 3/4. Okay, what is the decimal value of 3/4? Yeah. 75 hundredths, 0.75, a decimal that ends. Okay. We also have, as part of this definition here, one that ends or repeats. What's the mathematical notation to show that a decimal is repeating? Is that a hand up, Grayson? Yeah. Exactly. If you've got the number like 4.52 with a line over the 5.2, that decimal is actually 4.52525252525252. It really doesn't end, but it does repeat, and that still classifies it as a rational number. Okay. Yes?
When explaining whether a fraction is rational or irrational, can you just write it's a fraction because that's what Miss Sobiak let us do? That's
fine. Yeah, there are some fractions that are not rational. We'll kind of get to what those are in a little bit, but generally, yes. Okay. Well, it sounds like you've had experience then with rational and irrational. Yeah. What's an irrational number? Yeah. Well, repeating decimal makes it rational. Yeah, a repeating decimal, a decimal that ends or repeats, that is a rational number. An irrational number. Nick?
Got it.
Luke?
Something that will never stop, so kind of like pi, for example.
Does not end and does not repeat. Okay? An irrational number is a value with a decimal that does not end or repeat. A value with a decimal that does not end or repeat. And as Luke said, kind of the most famous irrational number would be pi. Okay, computers have calculated pi out to 2 billion decimal places. Still hasn't ended, and there's no sign of any repetition. Okay, who made pi? Well, see, there's a saying that kind of goes, humans. No human invents math. Humans discover it, right? Pi has always existed. Humans just discovered how to use it, right? Someone measured the diameter of a circle, compared it to the circumference, and realized, hey, the circumference is always about 3 times what the diameter is. And then they went to 3.1, and then 3.14, and 3. And it continued on. So it's always been. It's just humans discovered it. Question?
Kind of funny to think about the stuff that we do in our everyday life. Way back when, it was considered odd to be doing this stuff.
To be doing what? Sorry.
Math and stuff like that, discovering things. It was considered odd, like freaks, but now we use it every day.
Well, anything that's new kind of does. It's met with some resistance, I suppose. But yeah. Are these on topic? Okay. Trusting you here.
Like, what other numbers would we repeat on infinitely?
There's also a number E, which is like 2.3 or 2.6 something. That's used in Algebra 2 with logarithms and stuff. We'll get to that later. We're not gonna. Yeah. Other numbers where you'll see irrational would be like the square root of a non-perfect square. So there's the root of 12. Right? There are perfect squares and there are non-perfect squares. Perfect squares are numbers where you can multiply something times itself, to get that expression. The root of 16 is a perfect square because it's 4. 4 times 4 is 16. The root of 81 is 9. Perfect square. 9 times 9 is 81. The root of 12, though, there's no number that when you multiply it times itself gives you 12. If I gave you 12 dots, you could not make a square out of those 12 dots. You could make a 2x6 rectangle or a 3x4, but not a square. Okay? So when you're looking at roots, and there are some roots written here, including root 12 actually, you have to be thinking about it, what's the value of that? Root 81, even though it's a square root, because it equals 9, which is a decimal that ends, that would be rational. However, the root of 12 doesn't work out. So that's a decimal that goes on forever. Yeah?
Wouldn't exponents be an irrational since it's like the opposite of square root?
Well, actually, no. I mean, if you can square, if you square something, you get a multiple of that number. So no, it doesn't work the other way. Okay. The other thing for irrational numbers, there's a mathematical notation for those as well. What is the mathematical notation for an irrational number? A decimal that continues forever without repetition. If you've got a number like 10.8275 dot, that dot means that it goes on forever. It's kind of like when your parents send you a text message like, how was school today? And you respond with fine, right? There's more there than you're actually saying, okay? There's something else. When you see the dot, that is math's way of telling you that it is a decimal that continues on forever without repetition, and so it is an irrational number. Luke?
So like even stuff like 10 square rooted, that would be irrational.
An irrational?
Oh no, like wouldn't it be irrational? No, like I think there's a number that's like 3.3333, like infinite. That's like 10. No, it's,
Wait, one third.
yeah.
3 1/3 times 3 1/3 isn't
No, like
10.
it's like if you divide 10 by like 3, it like keeps on going like 3.33. Like
10 thirds? Yeah.
Yeah.
It's still rational because that decimal is 3.3 repeating.
Yeah. Okay.
Because it repeats, that makes it rational.
Yeah.
Okay? Okay, take a deep breath.
Good afternoon, students from Campus Monday afternoon announcements. I apologize they're late. I will make them very brief.
Live. Okay. Any questions on the definition of rational or irrational numbers? Your homework then, and you can kind of, like we talked about, identify the homework by looking at the Mr. Heavy Pencil sections. You've got two of them here. The first one says label each number as rational or irrational. Check your answer or defend your answer by explaining why you chose the category that you did. If all I see in your homework tomorrow is a bunch of R's and I's, okay, I'm not going to give you credit for it because I want you to defend why you chose that thing. You don't have to write a novel. I'm not asking you to write a paper about it. But if we look at, for example, the root of 36, and you decide that's a rational number, why? Because the root of 36 equals 6, and 6 is a decimal that ends. That's all I need. Okay? Yeah, and 6 being a decimal that ends, that's... Yeah, you don't have to write a novel. If we look at the square root of 8, is the root of 8 rational or irrational? Sebastian?
Irrational.
Irrational. Why, Sebastian?
Because it's not square. It can't be square rooted.
Right, it's a non-perfect square. Okay, that's it. Just a reason why. Why did you pick that? And I mentioned earlier R's and I's. For irrational, if you could put IR, I know it's a lot to ask, but the I has a couple different meanings in math that I don't want you to get in the habit of. Irrational should be IR. So if you could, hopefully it's not too much. Okay. So that section there, and then the three questions down below. The first one says, write the value of 7 3 ways: as an integer, as a fraction not in simplest form, and using a square root. Okay? The value of 7 as an integer, a fraction not in simplest form, and using a square root. So if I had asked you, for example, to write the value of 9 as a fraction in simplest form, what would be or not in simplest form? What would be a fraction not in simplest form with a value of 9? Sebastian.
2 and 1/4.
2 and 1/4 is not equivalent to 9. Yes. Camden?
18 over 2?
18 over 2, right? Remember that fraction bar really just means divided by? So 18 over 2 or 18 divided by 2 is a fraction that is equivalent to 9. It has a value of 9. And that's what I'm asking you to do here with 7. Okay? The second question says, in our number system, are there more rational numbers or more irrational numbers? So think about any number you could possibly think of. Our entire number system. Are more of them rational or more of them irrational? And again, I want your defense as to why. And then number 3, for review, describe whole numbers and integers. If you talked about rational and irrational before, my guess is you've talked about whole numbers and integers. So you might want to check your notes from last year, or the Google is also a resource that you can use. Okay, Luke, question.
This is for afterwards, but in geometry, can we work on this?
We'll cross that bridge when it comes.
Okay.
Okay. So homework, unless otherwise specified, is due the following day. So this is going to be due tomorrow. Remember, I don't grade on right and wrong. So I grade on whether or not you at least attempt everything. If there's something you don't understand, don't just put a giant question mark. Don't put IDK. Certainly don't put IDEC. Okay. Try it, and we'll talk about it tomorrow. If you'd like to email me tonight questions, all I'm going to do is watching football, so I got nothing better to do than answer them. That is totally I should correct your test. Never mind. My email is shut down. No, send me an email, and if I'm able to respond to it with help, then I can do that. Yes, sir.
What's like the sub at the top of the past and then the CO?
We'll talk about that a little bit later on. It doesn't apply right now. So I ask at the end of each video, we didn't talk about this before, so this will be kind of a live dry run practice. My outro is typically, that's how you math. When I say that's how you math, you all, in unison, together, respond with, don't forget to like and subscribe.
Oh, everyone wanted to do this.
So
No, you gotta go. This is Kevin's rules.
I will end this and we'll practice. So that's how you math.
Like and subscribe.
No. Don't forget to like, and you forgot the most, don't forget to like, okay, try it again. That's how you math.
Don't forget to like and subscribe.
That was the one.